In our last class, we went over some key terms to help us in simplifying variable expressions. We're going to see how well you remember these terms and see also if we can identify them in given expressions. Let's start by identifying some of these key words, the coefficients, the like terms, the constants, and we'll start with this 3m minus 2n plus n minus 4. Let's list the terms. There's a 3m. There is a negative, you take the sign in front, a negative 2n. You have an n, and you have a negative 4. Those are the four terms that make up this expression. Now let's talk coefficients. Coefficients are numbers that are in front of a variable, numbers that are multiplied by a variable. So we see that in this first expression, 3m, coefficient is 3. In a negative 2n, it's negative 2. In front of the n, well, you say there's no number, but we always know there's a 1. It's understood. So those are my coefficients. Second question is, are there any like terms? Well, like terms have the same variable raised to the same power. So I have a negative 2n and an n. We're just identifying the key terms. On to constants. Well, what exactly is a constant? It's a number that doesn't change. It doesn't have a variable. It remains constant. So negative 4 is my constant. Now, you might be asked to see if you could simplify this expression. Well, if I look carefully, these two center terms are what we call like terms, and they can be combined. I'd have a negative 2n plus 1n, and that's going to give me a negative n. So my new expression that is equivalent but simplified is 3m minus n minus 4. Nothing else to simplify here because these are all unlike terms. Let's take another look at this. I'm going to ask you to identify, and we'll do one at a time. Let's take a look at the first one. 6 plus 2w plus 4w minus 3. Right now, before I do any simplifying, I have 1, 2, 3, 4 terms. The question is, will it stay 4 terms or can I simplify it? We'll start with coefficients, numbers in front of variables. Remember, just the number, not the variable. Like terms, well, 2w is like 4w because they have the same variable, raised to the same power, and constants are also like terms. Speaking of constants, that's 6 and the negative 3 are constants because they are numbers without variables. If I take a look at this expression, I'm going to see that I have like terms right in the center here. So I'm going to combine them. 2w plus 4w is 6w. But wait, there's a 6 and a minus 3. These are also like terms. 6 minus 3 is 3. I have simplified, which is just equivalent to the original expression, and it has 2 terms. On to a second problem. I have negative 4r plus 3 minus 2s plus r minus 1 plus 6w. There are a lot of terms here. There are 1, 2, 3, 4, 5, 6 terms. We'll start by naming the coefficients, numbers in front of the variables. Negative 4, negative 2. Remember, if there's no number in front, it's a 1, and 6. Like terms, well, negative 4r is like r because the same variable raised to the same power. Negative 2s is like 6x. And I have 3 and 1. The constants are also like terms. Again, they ask for constants, and I just mentioned we have 3 and 1. So how about simplifying this? I'm going to now show you another method. Instead of rewriting it with commutative property, I'm going to use some shapes to recognize like terms. I'm going to put a circle around all the r terms, including the sign in front of it. So I have a negative 4r plus r, and that's going to give me a negative 3r. Let's go on to my constants. I have 3 plus 1. I'm using a different shape to recognize the different terms. That's going to give me a plus 4. And then I have a negative 2s plus 6x. Well, negative 2s plus 6s, unlike signs, subtract, keep the sign of the greater absolute value, gives me 4s. I have now simplified this expression. It's equivalent. I just neatened it up a little bit. Here, I'm doing the same thing. You're going to simplify a variable expression by replacing it with an equivalent expression that has fewer terms, as few terms as possible, which means we're going to combine like terms. I'll do 2 of these, and you'll do the rest. I'm going to start with doing my commutative property again, or in the next one, I'll show you how I use those shapes again. If I use my commutative property, I have 4x plus x. Then I switch the x and 5, so then I have the 5 minus 2. You'll see the 4x plus x gives me the 5x, and 5 minus 2 gives me 3. So what was 4 terms is now an equivalent expression with 2 terms, so it has as few terms as possible. In the second one, again, if I didn't want to rewrite it, I could sort of acknowledge the same terms by circling them or boxing them, however I want to. So I have 9x minus 6x, 9n minus 6n is 3n. And then I have some like terms in the center here. 8 plus 2 is 10. And again, it's equivalent, it's just simplified. In your next problem, you're going to have a distribution here. You need to distribute the 3 to the 4x and to the 2. I now have 12x plus 6 minus 3x. Again, like terms can be combined. 12x minus 3x is 9x plus 6. It's now an algebraic or variable term that's simplified. I'd like you to try the next 2, and we'll discuss these in class. One last thing I want to do today before we end the session is to take a look once again at how we can simplify expressions. We're going to look at ways that we can simplify condensing something into less terms, or as few terms as possible. When I look at the expression that starts off here, 9a minus 7a, I notice that they both have an a in common. If I take out that common factor of a, I'm simply then just subtracting 9 minus 7 to give me the 2a. This is another way to look at how you combine your like terms. It's, again, a reverse distribution. We don't have to do it this way. We could just say 9a minus 7a is 2a. But if you wanted to see technically how it comes about, this is what you're doing. In my second problem, I'm first going to do my commutative property. Now that I have rearranged it, I notice that these both have a k expression part to it. So I'm going to remove the k, and I'm left with 5 minus 8. Well, 5 minus 8 is going to be negative 3. So negative 3 times k minus 4 is my expression. And again, if I started it from here, I could just say 5 minus 8 is negative 3. 2 ways to look at the same problem. So I'll leave you with that example, and we'll practice more in class.